All right. Page 143. Pause the video and write down all your derivatives of trig functions. Okay. Here we go. All right, so this is 6.2, anti-differentiating exponentials and trig functions. Trying to get my screen right. There we go. So we learned the power rule, scalar multiple yesterday, increase the power, divide by the new power, that sort of thing. And today, we're using all of our trig rules, trig derivatives, to anti-differentiate. So, for instance, the antiderivative of cosine of x is sine of x plus c. Again, a good idea is to check by just doing it real fast. Go backwards. The derivative of sine is cosine. Yes, I did it right. Okay. So for all of these things, as long as you know the derivatives, then the integrals are easy as well. I also want to remind you that so cosecant is 1 over sine. And cotangent is what? Cosine over sine. Cosine x over sine x. And so it's important that when you see trig functions, when you're doing them and integrating them or taking derivatives, remember that they might be in different forms. So they look totally different, but really it's something like this that's super easy. Okay, so you want to think about how something like this could be split apart into something we have a shortcut for, shall we say. Okay, so keeping that in mind today, there's a couple problems that you'll see that on. And in general, most of the time, we would use sines and cosines. For instance, I wouldn't change this to 1 over tangent most of the time, because sines and cosines is typical. But shouldn't be too bad. The most common errors made with trig functions are sign errors. So this comes from the unit circle. And if you think about the unit circle, this point is 1, 0. And if you'll remember, cosine of x is the x coordinate, and sine of x is the y coordinate. And as you move around, this is telling us that here, these cosine values are all positive. And in fact, everything here in quadrant 1, the cosine values are positive. And again, up here, sine is also positive values. If you imagine we're up at the point 0, 1, the sine values are positive. Over on the left side here, again, when you think about the ordered pairs here, negative 1, 0, all on the left side here, we have cosine values are negative. And then down here, again, 0, negative 1, sine values are negative because we're below the axis. So these things, cosine is positive, sine is positive, cosine values are negative, sine values are negative, basically come just from those ordered pairs. And so it tells you if we want to do derivatives, we start with sine. Derivative of sine is cosine. The derivative of cosine, negative sine. The derivative of negative sine, negative cosine. So it just works its way around. And if you want to do antiderivatives, you go counterclockwise. So if we wanted to put the antiderivative of negative sine, cosine. The antiderivative of cosine, sine. The integral of sine, negative cosine. So I don't find it hard to remember, but because I just work with the negatives for the most part. So anyway, that might be helpful. And it's pretty easy to write down. It makes pretty good sense. All right, so we want to just practice these antiderivatives. This is a lovely little scalar multiple, so technically we could just pull that out in front, multiply it out in front. And what is the antiderivative of sine of x? It is. So we have a -3, and then that would be times negative cosine of x plus c. How do I know? I'm going to double check. I'm going to take the derivative of this. I know that the derivative of cosine is negative sine. Negative times negative is going to give me positive sine. All right? So it's always a good idea to double check. And that's why I don't mix up my signs, because I'm always going to just double check really fast on these sort of things. Negative times negative is positive, so 3 cosine of x plus c for that one. Here on number 2, we have integral of each piece. We could separate it if we wanted to, but it's not necessary. I'm going to do it just for this first one, minus 2 to the x dx. So I have the integral of e to the x dx minus the integral of 2 to the x dx. All right, what's the antiderivative of e to the x? E to the x, that's an easy one. And then, what about our 2 to the x? Two to the x times over. No, you're right, over. What did I do there? Oh, what's the difference here? This is the derivative. Yeah, so this is the derivative. We had to multiply by the base factor. Yeah, no, but at the top. So on this one, you can see we have to divide instead of multiply by that. And essentially, it's like a chain rule. All right, so we're gonna do this in the next unit. So instead of multiplying by that natural log of a factor, we have to divide by the natural log of a factor. So divide by the natural log of 2, and then plus c. You know what? I'm just gonna make sure that those are right originally. I copied them down. Let me double check. Let me double check. Yeah, okay. Yeah. So the derivative is multiply by the natural log of a. When we integrate, we're going to divide by the natural log of a. And you're going to see that sort of operation done a lot as well, just like we divide by the new power. All right, here we go. What do I need to do with this first term here? Turn it into a power. Yeah, absolutely. So we have a 5t to what power? 2/3. Good. Plus 3 cosine of t minus 1 dt. All right, so we are going to increase the power by 1. So I'm going to add 3/3 on there. I use a separate color, but this is actually pretty bad notation. I would never do this on an AP test. All right? That's notation that is now wrong. Like, it's just, you've modified the problem, changed the value of the equation, okay? It's something you could write way over on the side, clearly far away from what you're doing, if you needed to. This is just notes, though, so I just want to point that out. Okay, so we have increased the power, so that would be t to what power? 5/3. And we're going to divide by the new power or multiply by the reciprocal. Yeah, multiply by the reciprocal. I'm going to multiply by 3/5 instead of dividing by my power. And the reason I'm doing that is because then I can clearly see that my 5s are going to reduce. Something like that is okay to do. All right, what's the antiderivative of cosine? Sine. So we would have 3 sine of t. And again, I'm just going to double check. The derivative of sine is cosine. So I know I did that one right. And then the antiderivative of 1 dt, negative 1t. All right, plus c. So we have 3t to the 5/3 plus 3 sine of t minus t plus c. All right, I love something like this. Looks really complicated, but divide by 4 is a scalar multiple. You can think about it as a 1/4 that we could take out in front of our integral. So anytime we have a scalar multiple multiplying the whole thing, we can pull that off in front. Secant of y, tangent of y, dy. Secant y, tangent y. Where did secant tangent come from? Secant. So the antiderivative of secant tangent is just secant y plus c. So again, study those antiderivatives. Make sure they make good sense to you. All right, and then here, what are they giving us? They're giving us f prime of x, so they're giving us a derivative. And this is cosecant squared of x. You'll notice he used old school notation, which I like so much better. And they gave us an x and a y for the original function. They want us to find the original function. So what do we need to do? How do we find f of x? Integrate the derivative. Yeah, integrate f prime of x dx, which is the integral of cosecant squared of x dx. All right, what is the antiderivative of cosecant squared? Negative cotangent. Yep, cosecant squared is negative cotangent. All right, so we have f of x equals negative cotangent of x plus c. And then we can do what? Plug in the initial condition, sure. The function value is 3 when cotangent of x of 5 pi over 4 plus c. All right, how do we do that? I'm going to do a little for giggles here just to remind you. Circles and dots. 5 pi over 4. Pi divided into 4 equal wedges means, there we go, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is right here. And that ordered pair is negative radical 2 over 2 and negative radical 2 over 2. Good. All right, so what is the cotangent of that? Yeah, cosine over sine is cotangent, and those divided by themselves is just 1, all right? It has a negative in front of it, so that's going to be 3 equals negative 1 plus c, which means c equals Did I do that right? That's so funny. My answers are different here. I'll have to double check. Cotangent, that would give me positive 1. With a negative should be negative 1. All right, I think it is 4. We good with that? So then we have to find the original f of x, which just plugs in our c value. So negative cotangent of x plus 4. All right, I'm going to double check that answer to make sure I didn't goof. Most of today's problems on the worksheet come straight out of here. Right here, this one is complicated. What should you do first? Yeah, how do you get rid of the x? Oh, so we can't, it's not a scalar multiple. We can't take out the x to the outside of the radical or outside of the integral. But what is this x doing? Dividing each, dividing each term. So if you think about it, this is 4x to the 4th divided by x minus x e to the x divided by x dx. So those x's reduce, and x to the 4th over x also cleans up. So we would have 4x cubed minus e to the x dx. I didn't give you this one, but these are things that I need you to make sure you understand. This has a 1/5 So that 1/5 could come out. But for the most part, that's a great thing. All right. Any questions? Pretty easy? Yeah? All right. Let me stop that. I'll check that answer, and I'll pass out your worksheet.